In this problem, we need to resolve the given rational fraction into partial fractions. So let's begin. First, we're going to suppose that this rational fraction, which is x cubed, divided by the factors x plus 1 whole squared times x minus 2 whole cubed. So this can be split into 5 partial fractions. That is because x plus 1 is repeating twice and x minus 2 is repeating 3 times. So a partial fraction will be a divided by x plus 1. So only taking one single factor x plus 1. Then in the next partial fraction, we're going to have b over x plus 1 whole squared. Then in the third partial fraction, we're going to have c over x minus 2. We'll only consider one factor of x minus 2 out of x minus 2 whole cube. Plus the fourth partial fraction will be d over x minus 2 whole squared. And finally, the fifth partial fraction will be e over x minus 2 whole cube. So let's label this as equation number 1. So our task will be to find out the value of a, b, c, d, and e. Now what we'll do, we're going to use a method known as the cover-up method. So cover-up method is going to help us obtain the value of few of the constants, but not all of them. Using cover-up method, we can actually only find out the value of the constant b and e. That's because if we look at the denominator of b, that contains the factor x plus 1 whole squared, which is present on the left-hand side of our expression or the original rational fraction. Similarly, if we consider the fifth partial fraction here, the denominator is x minus 2 whole cube. So that factor is also present on the left-hand side of our expression. So what does the cover-up method tells us? So to find out the value of b, all we have to do is we take the rational expression on the left hand side and cover up the factor x plus 1 whole squared. So that means we're only left with x minus 2 whole cube. So what would we cover up? We covered up here x plus 1. So if we are whole squared, and if we equate it to 0 and solve for the x value of x, so that will be negative 1. So what we'll do? We'll substitute our value of x with negative 1. So this is going to give us, we have negative 1 whole cubed divided by negative 1 minus 2 whole cubed in the denominator. So that's negative 1 divided by negative 3 whole cubed. So that's negative 27. So our b value comes out to be 1 over 27. Fine. Now coming to the fifth partial fraction. So from there we can find out the value of e. So here e, the denominator has a factor x minus 2 whole cube. So we'll come back to our original rational fraction when we cover up the factor x minus 2 whole cube. So we're left with x plus 1 whole squared in the denominator. So what did we cover up here? We covered up here x minus 2 whole cube. So if we equate it to 0, this is going to give us the value of x equals to 2. So we'll substitute x with 2 into our expression. So we have 2 cubed, so that's 8, divided by 2 plus 1, so that's 3 squared. So 3 squared is 9. So our e value comes out to be 8 over 9. So we'll set this two values aside. Now coming back to equation number 1. So from equation number 1, what we're going to do, we're going to multiply throughout with the denominator x plus 1 whole squared and x minus 2 whole cubed. So on the left hand side, we're going to have x cubed. On the right hand side, we're going to have x plus 1 multiplied to x minus 2 whole cubed times a. That's the first term. The second term will be x minus 2 whole cubed times b. The third term is going to be x plus 1 whole squared multiplied to x minus 2 whole squared times c. The fourth term will be, so we have x plus 1 whole squared multiplied to x minus 2 times d. And finally, the fifth term, that's going to be x plus 1 whole squared times e. So let's label this as equation number 2. Fine. Now we can see here that this equation is an identity in x. So since it's an identity in x, what we can do, we can take few values of x. So let's consider x to be equals to 0. So if we take x equals to 0 and substitute it into our equation number 2, so that's going to give us, let's write it down. So equation 2 will then give us 0 cube will be 0. So this is going to give us the value. So we can plug in the value of x with 0 and we should get negative 8a minus 8b plus 4c minus 2d plus Then we're going to consider another value. So let x equals to 1. So if we replace the value of x with 1 in equation number 2, then equation number 2 now becomes 1 equals to negative 2a minus b plus 4c minus 4d plus 4e. So this is another equation, and then we're going to consider one more equation. We're going to take 3 equations. Although we have like 3 unknowns here, a, b, c, d and e, we should actually have 5 equations in order to solve this equation, solve for the values of the constants, but we'll only consider 3 equations. That's because we already have obtained the value b and e, which we'll be replacing once we write the other equation. Now this time we're going to take the value x equals to 3. We're not going to consider x equals to 2. That's because we have already considered x equals to 2. The equation number 2 now becomes, so we have 3 cubed on the left hand side, so that's 27. The 27 is going to be equals to 4a plus b plus 16c plus 16d plus 16e. So we have now 3 new equations. So let's label this as equation number 3, 4 and 5. Now what we'll do, we'll use these 2 values of b and e. So b is 1 over 27 and e is 8 over 9, and substitute that into equation 3, 4 and 5. So let's do that. 4a minus 2c plus d, so that will be equals to 8 over 27. Then we're going to get a minus 2c plus 2d, that will be equals to 34 over 27, and the third equation is going to be a plus 4c plus 4d, which will be equals to 86 over 27. Now let's label this as equation number 6, 7 and 8. Now what we can do, I'm leaving this as an exercise for you. You can solve equation 6, 7 and 8. This is the simultaneous linear equation with variable a, c and d. So solving this equation, we're going to get the values for a, c and d. So a will be equals to negative 2 over 27. C value, that will be equals to 2 over 27, and d value, so that will be equals to 20 over 27. So finally we have obtained the value of all the 5 constants. We will substitute them back into equation number 1. So therefore we have x cubed divided by x plus 1 whole squared multiplied to x minus 2 whole cube. So our first partial fraction will be negative 2 divided by 27 times x plus 1. Then we have 1 over 27 times x plus 1 whole squared, followed by 2 over 27 times x minus 2. Then the fourth partial fraction is going to be 20 divided by 27 times x minus 2 whole squared, and the fifth one is going to be 8 over 9 multiplied to x minus 2 whole cube.